Okay guys, here we go. We are going to add geometric dimensioning and tolerancing to our project. We have a couple of drawings requiring GD&T. We have the body, which is going to require GD&T. We have the jaw, we have the main screw, and we have the bottom plate. I'm not going to do the bottom plate for you. You guys should be able to do that after I show you what to do with the other three. So we're going to start with the body, and we're going to use the same workflow for each drawing. We're going to need you to take some very, very good notes here. I will repeat a little bit, but for the most part, I'm going to expect you to take good notes. Now, for this lecture, I usually put a workflow list on the whiteboard for you, but that's a little bit hard to do while I'm working on the laptop in AutoCAD. And so I'm going to verbally say the things that I would have written on the whiteboard. And so you're going to need to write some things down so you have a good formula and how to step by step kind of thing in your notes should you need that list on your final exam. Okay, so here we go. We're going to start with GD&T on the body drawing. And as you recall, I had you ignore the feature control frames and the datum feature symbols. And I had you go ahead and use the basic dimensions which appear in the box. Now, if you have not yet watched the video from last week on geometric dimensioning and tolerancing, you really need to watch that first. Okay? So there's an order in which I always kind of have set or established for myself so that I don't forget things. And part of that workflow is specific to GD&T. And so I'm going to share that with you. And what it is item number one when applying geometric dimensioning and tolerancing to a drawing. Of course, first of all, I already have the drawing. I already have the views. I already have all of the dimensioning done. We're now going to add to it the geometric dimensioning and tolerancing. Now take note that the numbers that appeared on our handout as basic dimensions, they are here. They're just not basic dimensions yet. I'll show you how to turn them into those in a moment. But before we do that, the first thing we want to do is we want to, item number one, correctly identify the datums. So we have datum A, which is the two bottom surfaces of the part, datum B, which is the front face of the part, datum C, which is the right face of the part, and datum D, which is two surfaces. That's this surface and this surface that the jaws sit on while the part is in its working position. So here's the deal with datums. All of these datums are surface datums. Remember, a datum can be a surface, axis, line, point, or plane. These are all surface datums. They're simple. And what happens with a surface datum is the surface datum is applied. Listen carefully and write it down. A surface datum is applied to the view where the surface appears as an edge. Okay, so one, a surface datum is called out, or that symbol is placed on a view where the surface appears as an edge. Okay, so if we look at datum surface A, which is two surfaces, that surface appears as an edge in the front view, and it appears as two edges in the right side view. And since it is a coplanar datum, meaning made up of multiple planes, it makes sense that it would be the best choice to place that datum call out in the view where I see the two edges, which would be the right side view. Okay. Now, the datum surface symbol, datum feature symbol, can be placed on the actual edge or an extension of the edge as long as it does not line up with an arrow for an existing dimension. Okay, so here we see that datum surface A or datum feature A, the symbol is placed right on the surface itself. That's acceptable. It could also have been placed out here on this extension line as long as it doesn't line up with the arrow for a dimension. Okay, now we decided we're going to put it into the right side view. I can put it on this surface here. I can put it on this surface here. I can put it on this extension line as long as it does not line up with that arrow. Okay, so let's go over to AutoCAD. So we decided we're going to place it in the right side view where we can see both surfaces, and we can place it either on this line coming down or on this line coming down or on this extension line as long as it doesn't line up with the arrow, or on this extension line as long as it doesn't line up with the arrow. Okay, now we have a little bit of work to do with the Dimension Style Manager before we place that symbol. So let's go do that. On the Annotate tab, I already have my ASME Dimension Style running. I'm going to go to Dimension Style Manager. I'm going to choose my ASME style, and I'm going to go New. And I'm going to call it Datum. And I'm only going to change one thing in here. On the Symbols and Arrows tab, notice the leader call out here for arrowheads. I'm going to change that to Datum Triangle. Now, don't use datum triangle filled. Some versions of AutoCAD, that doesn't work very well. So use the datum triangle. I'm going to click OK, and I'm going to close. Notice it is now the current dimension style. And I'm going to use the leader command to get this symbol. It's going to go like this. Leader, type it in. This is not a multi-leader. It's the leader command. Type it in. Specify the start point. I'm going to grab the midpoint of this extension line, and notice I'm going to pull just far enough, ortho is on, I'm going to pull just far enough that that little datum triangle pops up, and I'm going to select. And now remember, this is the leader command, so it's wanting you to draw a shoulder, etc. I'm going to do this. Notice my default is to go to annotation, and it seems counterintuitive, but I'm going to go ahead and enter and take that annotation, and then I'm going to enter for options, and then I want N for none because I don't want any annotation. So it's leader, pick, enter, enter, N for none, and enter. And what that's going to do is it's going to give us the stand for that datum feature symbol. Now, to get the rest of the datum feature symbol, we're going to pop down the dimension roll down. And the very first item on the pull down says it's tolerance. But if you look at that, that's our feature control frame. It's all of our GD&T. Now, all we want is a datum identifier. In this case, we want a capital A. We're going to have to put that down and then move it. And we're going to attach it right there, datum feature A. Now, this could go here where it's at. It could go here. It could go here. It could go here. It cannot go here because it is not allowed to line up with that arrow. It cannot go here because it's not allowed to line up with the arrow. I'm going to leave it right here. And this particular call out needs the note underneath it that says two surfaces. So I'm going to use dynamic text here. I'm going to make sure my height is 0.125. And this is going to say two surfaces. Okay. Now, why isn't my text 0.125 high? Okay. Well, it's not 0.125 high because my current text style is not an annotative text style, and my scale is not 1 to 1. My scale is 3 to 4 here. So that's not going to work. I need a different style. Let's use our notes style. Did you know I can take that and go drop it onto the note style to make sure that it is 0.125? Okay, so that's our first datum call out. The next one is datum B, which is this front face. Now, where does this surface appear as an edge? It only appears as an edge here in the right side view. So here we go again. We're going to do this again. Leader. I'm going to select here, pull, pick, enter, enter, N for none. And then I'm going to go use my tolerances option, datum identifier B. I'm going to put that down, and then I'm going to have to move it. I'm going to move it from its midpoint to this endpoint. Okay? Datum A, datum B. Next, datum C, which is the right face. Now that only appears as an edge in the front view. So into the front view, leader. Well, I'll take it here. Pick, enter, enter, N for none. And this is going to be datum C. Okay, datum D is these two surfaces here. I can only see that here on this face. So leader, pick, enter, enter, N for none. That's going to be datum D. Okay, and again, this is going to get the note two surfaces. Whoops. Okay, and I tried to kind of center that. Okay, so that was task number 1. Correctly identify our datums. Task number 2 is to locate the things that are going to be applied by surface. Now, what does that mean? This control, perpendicularity, this control, parallelism, flatness, any of these sorts of controls that are going to control one surface to another surface. These are surface controls, and surface controls go next. So here's one here. I have perpendicularity, I have a parallelism, and a perpendicularity. Now these, listen careful, here's the rule on these. These must be applied on the view where the surface appears as an edge. Okay, that's rule 1. These must appear on the view where the surface appears as an edge. And they hang as a flag at the end of an extension of that surface. So you have to have an extension line for these. Okay, if you don't have an extension line, you can draw one if you need to. Okay, we're going to begin with this surface. Where does this surface appear as an edge? It only appears as an edge in the front view, and it is perpendicular. It is perpendicular to surface A within 0.001. So here we go into our front view. This is the surface we're talking about right here. And so first thing I'm going to do is I'm going to build a feature control frame. I'm going to go to symbol, perpendicular, 0.001 to datum A. Is that right? Perpendicular 0.001 to datum A. I'm going to click OK, and that's going to draw my feature control frame. Now I can't leave it in outer space. It needs to hang as a flag at the end of this extension line. Now this is a problem because these are a little bit too close together. So I'm going to move this a little bit, and I'm going to go ahead and take a line segment, just a regular line, and extend that extension line so that's hanging as a flag. Look, it looks like a flag on a flagpole at the end of the extension where this face appears as an edge. Okay, let's do another one. This surface right here, this surface is parallel to A within 0.001. So where does this surface appear as an edge? Again, it only appears in the front view. So I'm going to go to the front view and I need an extension of this edge and there isn't one. So I might need to change some things around. I might need to change the way I've dimensioned this. In fact, I'm going to take the overall dimension to the opposite end of the part, make sure I'm adjusting my O-snaps. And I'm going to take this reference dimension to the outside over here, make sure I'm adjusting my O-snaps. Now, I can eliminate the hidden line as long as I add a note, some hidden lines omitted for clarity. And what that does is it gives me a clear extension line to put this feature control frame. So here we go. Parallelism within 0.001, datum A. And I'm going to move that so that it hangs as a flag at the end of the extension of that. Now, you cannot have this line up with an arrow. It's got to be far away from that. You can't have that arrow coming down there. So you might want to bring it out just a little bit. Okay, let's do another one. We have the front face, which appears as an edge in the right side view, perpendicular to A at 0.001. So we need that to hang as a flag off the extension line. So here we go, perpendicularity within 0.001 to datum A. I'm in the wrong viewport. Let's open the right viewport. Perpendicularity 0.001 to datum A. Okay, we're going to move that. I got really close to that, didn't I? Oh, I got lucky. Okay, so that's hanging as a flag at the end of that. Okay, so we're good on those. Those look good. Okay, next, we're going to add positional controls. We have two of them. We have this one, and we have this one. Here's the thing with positional controls. Positional controls should read as if they are part of the call out for the size of the object or the feature. So in this case, the feature is the tapped hole, 0.62511 UNC2B. This feature control frame should read as part of that call out. So it's going to go as a second line of text here. So we have position at diameter 005 when this is at maximum material condition, and make sure these are in the correct order, C, B, D. Okay, so here's that whole call out. We're going to go make a feature control frame, position at diameter 0.005 when this is at maximum material condition to C, B, and D. We're going to click OK, and that's going to read as the second line of information under that whole call out. Make sure we got that right. We do. This one, position 0.005 at maximum to B, goes with this size call out right here. Okay, now that appears on my right side view. Okay, we've got a problem here. First of all, this doesn't have its tolerance yet. So let's go make sure that it gets its tolerance. It should be 1.005 to 1.015. So let's take this. Let's right click and go to properties. let's take it to tolerance limits, and the upper limit needs to be adjusted by 0.010. Yes, yeah, 0.015. Okay. Is that correct? 0.005, yep. All right. So now I need a second line here. The problem is it's not going to fit. So if I go build it, position, there's no diameter here because this is not a diameter. 0.005 at maximum to datum B. Okay, so this needs to be associated with that call out, and it doesn't fit. So I'm going to put it aside. And what we're going to need to do is we're going to need to redistribute how we've dimensioned this. So I'm going to take the 995 and I'm going to pull it to the outside of the part, make sure I'm adjusting my O-snaps. And I'm going to take the 150 and I'm going to swap it so that it's the one to the inside, adjusting my O-snaps. That's going to allow me to pull this guy down free and clear, which will allow me to move